All right, let's get into it. The invisible fence. I mean, what a cool title, right? We're going to explore how a simple beam of light is creating this totally revolutionary kind of fence. And this isn't just some niche gadget. It's solving a massive billion-dollar problem in a way that's, well, it's just incredibly elegant and effective.
Yeah, and a silent war is actually the perfect way to describe it. Across these gigantic farms and our busiest airports, we are locked in this constant and very expensive conflict with birds. We need to protect our food, we need to keep our flights safe, but the old ways of doing things are just not cutting it anymore. The stakes here are unbelievably high.
For years, the go-to solutions have been things like propane cannons, those super loud booms, and other noisy pyrotechnics. But there's a fatal flaw. Birds are smart. They figure out pretty quickly that all that noise is just a bluff, and they just start to ignore it. It's a phenomenon called habituation. The laser, though, it's silent, it's precise, and for one very, very specific reason, birds just can't get used to it, ever.
Which kind of brings us to the core question, doesn't it? If a bird can learn to ignore a literal explosion, what is the one thing that its hardwired, basic survival instincts will never let it dismiss? The answer to that? Well, that's the whole secret to this technology.
Okay, let's get into the science of it all. Because this is so much more than just, scaring birds with a bright light. It's actually a really sophisticated hack of their fundamental biology.
To really get the hack, you have to understand the hardware it's running on. And a bird's eye, it's like a super processor. It's an absolute marvel. They see the world in a way that's completely different from us. They have 4 color cones, so they see colors we can't even imagine, including into the UV spectrum. And, this is the most important part, they process movement at an incredibly high speed.
So why a green laser? Why not red or blue? Well, it boils down to 2 main reasons. First, it turns out that most birds' eyes are just especially sensitive to the green part of the light spectrum. It really stands out to them. And second, that specific wavelength of green light scatters in the air in just the right way to make it look more, well, solid and visible, even on a cloudy or dusty day.
And this right here, this is the absolute aha moment. Get this. Because of their super fast visual processing and their sensitivity to green, a bird doesn't see a beam of light. To them, it's a physical object. It's a stick, or maybe it's a predator, swooping right towards them. And this triggers that deep, primal survival instinct. Get out of the way of the thing that's about to hit you.
So that's the biology. But what's really fascinating is how engineers have taken that single insight and built it into this incredibly powerful piece of technology. I mean, we've gone from a simple concept to a fully autonomous system.
In the beginning, this was a completely manual job. We're talking about someone literally walking around a field with a handheld laser. Not exactly efficient. But fast forward to today, and we have automated towers that can cover huge areas with pre-programmed patterns. And the really cutting-edge systems? That's where AI and computer vision step in to create something truly intelligent.
These modern systems are just packed with sophisticated features. They've got these precision motors for pinpoint accuracy. You can map out safe zones and deterrent zones, so you can tell it exactly where the laser should go, and, just as important, where it shouldn't. They use randomized patterns so the birds can never predict what's coming, and the newest systems can even use AI to identify a specific kind of bird and only activate when that particular target shows up. All right, so let's look at where the rubber meets the road. How is this technology actually being used to solve real-world problems? The impact is already being felt in some really big industries. The applications are incredibly broad. First, you've got agriculture, especially with high-value crops like berries and grapes that birds love. Then there's aviation, where bird strikes are a massive safety concern. And you even see them in industrial settings, like big warehouses, where nesting birds can become a serious health and logistics problem. And the results are just staggering. To put it in perspective, one blueberry farm in Oregon installed an automated laser system and reported a 90%, that's 90, a 90% reduction in crop loss. That's a massive, massive return on investment. And it was all achieved silently, without bothering a single neighbor.
Now, in aviation, the goal is a bit more nuanced. You don't want to just panic a huge flock of birds and accidentally scare them into the path of an airplane. So the laser is used more like a physical barrier, allowing operators to gently push or herd the birds away from a runway. It ensures a controlled, safe dispersal before takeoff or landing.
Of course, no technology is a perfect silver bullet. So let's take an honest look at some of the challenges and what the future might hold for this innovation. This is a really important question.
And the answer, according to animal welfare experts, is yes. Because the laser only triggers a natural flea response and it never ever makes physical contact, it's considered a humane alternative to things like poisons or nets. It causes no physical harm or lasting trauma. You know, this chart really sums it all up beautifully. When you compare automated lasers to all the traditional methods, they just come out on top in almost every single category. The habituation risk is low, they're silent, they're super effective, and the long-term cost is surprisingly manageable.
But there is one major challenge: the sun. In bright, direct daylight, the laser's contrast against the ground is much lower, which can make it less effective. This is the biggest hurdle they're facing, but researchers are actively on it, looking into things like high-powered pulsed lasers that might be able to cut through the daylight.
But the future probably isn't just about lasers. It's more likely about creating an integrated, multimodal system. So imagine combining the visual threat of the laser with, say, the sound of a predator's call played over a speaker. And if that doesn't work, maybe you deploy a drone for a little physical chasing. Now that is the ultimate smart deterrent system.
So what does this all add up to? When you take a step back, you realize this is more than just a new gadget. It's a fundamental shift in how we think about managing the conflicts between human activity and the wildlife all around us.
This really is one of those incredibly rare situations that presents a true win-win-win. Farmers get higher yields, which is a huge win. Air travel becomes safer for all of us, which is another huge win. And we get to achieve all this with a solution that is respectful and non-lethal to the birds themselves. It's just a better way.
And it leaves us with this really powerful thought. By understanding biology through the lens of physics, we've managed to create a brand new kind of boundary, a silent, effective, and intelligent barrier that shows us a new path forward for how we can coexist. The fence of the future, it really is made of light.